In this video, we're going to be taking those simple forecasting methods that we just learned and put them into action. Now, the first step we talked about was data preparation and data visualization. So here we're going to deal with the Australian production data set right here, Aus_production, and we are going to extract the beer production from that. So in this first step, what we're doing is we are trying to set our training data from 1992 to 2007. You can make it what you want, but the nice thing to do always is to try to look at your data set first before you apply these commands. So we're going to define our training data set and assign it to this type of an operation here. So we're going to take Australian_production, use the pipe function on it, and then we are going to filter between 1992 and 2007. There are two ways you can do this. You can filter and say between your quarter, because this is quarterly data, 1992 and 2007. So this is your starting point and this is your end point of your subsample. Or you can use the command filter_index and say 1992 quarter 1 and the squiggly here or tilde 2007 quarter 4. So it has to be written this way or this way. It's up to you what you want to write. So that's your first step. You've defined what your training data set is. Now, the train is not going to have just a beer production. It's going to have many other things that are in the data set. So you should try to head your data set, head train, and see what it looks like. But now we can try to just focus on beer production by saying train pipe function auto plot beer, and this is what it looks like. So this is beer production over time. This is our step, the first two steps here, that we've extracted the data and we visualized it. The third step involves the estimation of a model. Now, because we are in the tidyverse or tsibbles, right? We are going to use this powerful function called the model function that trains different models to data. So the beauty of this function is that it can accommodate many models at once. Earlier, when we weren't dealing with tsibbles and different functionalities of packages, we were limited where we would have to estimate one model at a time, which was tedious, and now you're able to do that at once. So we'll fit the models. We're going to define the fitted model as beer_fit, and we're assigning beer fit to this operation where we take the training data and we are going to use the model function and specify the 4 different types of models that we have learned here. So the mean model, so we're going to call that mean, you can call it what you want, equals mean, which is the function here, on beer, right? So we're extracting beer from that train set here. Naive, which is using the naive function on beer. You can also use RW here if you don't like naive. And then seasonal naive using the S_naive function on beer. And finally, the drift model, which is using the RW function, but you have to specify a little bit more here where you say beer tilde drift and you close the brackets. Okay, so you're going to close the brackets out, and what you are going to get is going to be, so when you type in beer_fit, you are going to get a Mabel. A Mabel is a model table where each cell corresponds to a fitted model. So what we have here is saying that we have a Mabel has 1 row and 4 columns, and the 4 columns correspond to the 4 different types of models that we have estimated. So mean, naive, seasonal naive, and the drift model. And you can see the description here as well. Now let's see what it gives us. The last step here, so going back to, so one more thing I want to mention here about Mabel is that your model column becomes an additional key that you can use to do other things. So here you see that we had identified keys in the previous video. We can use these keys to do other things, and we can get to that later. So in our last step, we're trying to produce forecasts. Once we have estimated those models, we want to forecast ahead, and here we can try to assign this operation of forecast to beer underscore forecast. So beer underscore FC is our forecast, which is going to be derived from beer underscore fit, which contains those 4 models. And we're going to use the pipe function on it. So we're using those models, whatever we trained those models to do, using the training data set, we are going to use the pipe function on it and forecast H periods ahead. So here, H is going to be in quarters because you have quarterly data. So this is 11 quarters ahead. Okay, so you can imagine that because you have 4 different types of models and you are forecasting 11 periods ahead, you're going to have 44 values. Okay, 11 times 4 from different models. And what you get is a fable. Okay, now a fable is a forecast table with point forecasts and distributions. So a fable is going to have different keys again. The dot model column is going to be working as a key. So if we wanted to focus on just this column, we can extract that using that key. We also have the distribution column here, which is to say that we know the distribution of our forecasts, which are the estimated probability distributions of our forecasts. And we also get this column here, which says beer. These are our point forecasts, okay, which are going to be just the forecast from the different models. Okay, so both of these are important. Now, the fable doesn't automatically give you prediction intervals, which we'll talk about later, but the HILO, H-I-L-O function can give you those prediction intervals as well. So we can get to actually visualizing our forecast, which might be easy to eyeball and see which models are performing better when we are talking about beer production forecasts. So we can say then that beer FC, beer underscore FC, which take the forecasts and auto plot them. Okay, auto plot not just the forecasts, but also the training set. Okay, so if you just say auto plot train, it's also going to give you these prediction intervals, the 80 and 95% prediction intervals. So if you don't want those, you can get rid of it by saying level equals null. It gives you a cleaner graph if you have too many models that you're trying to plot together and compare. And you can give your graph a title, which is just saying forecast for quarterly beer production. You can label your X and Y axes here, and then you can produce a beautiful legend by using guides here. And the guides are going to automatically assign different colors for your forecast. So you can see the 4 different models here that are represented. We know that the mean model is just the average of the time series before. So this does look like the average of the time series. The naive model is just going to be equal to the value of the last value in the series, which is this guy here. And the seasonal naive is going to kind of mimic that pattern that you see in the data, because it is going to assign the value of the forecast should be equal to the last, the value in the last season for the previous year. So this is what you see, and this sort of stays the same because you're kind of estimating this 11 periods ahead standing at this point here. Okay, so it's going to take those values from here and try to mimic the data. And then finally you have the drift forecasts, right, which is this red line here, which shows you that this is just, if you were to extrapolate a line joining this last point here in your training data set and the first point here and extend it, that is your drift forecast. You can also use auto layer in addition to all of this code here to actually overlay or superimpose your actual time series on your forecasts. But we already know which model is a winner here. So seasonal naive seems to mimic that pattern very well. We can take this idea and do a more involved exercise by looking at financial data. So GAFA underscore stock is already loaded if you have the FPP3 package installed. Now, you can try to look at different types of stock prices from that data set. It has a lot of different types of stock prices, and you can extract your training data in this way. So if we were focusing on the Facebook stock, we can call this FB underscore stock. We are now going to extract the Facebook ticker, right, using the symbol by doing the following operation. So the first thing we want to do is we take that entire data set that has all these stock prices, use the pipe function, and we use the group by command. We say group by symbol. So any operation that you perform in the future is going to be performed by the group. Okay, and the group is going to be defined by the symbol. So you're going to take each company differently. Okay, so each company that has gone public and that's in your data set is going to be treated differently, and those operations will be performed on that. So then we use the pipe function again and we mutate our data set. The mutation is important because the stock market isn't open all the time and you want to specify a correct time index. And so if you don't recall this, I would refer you to chapter 2 videos. So we mutate this by saying trading underscore day equals the row number. So you're actually just saying set up a new time index based on trading days to replace the irregular calendar days. Okay. So once you've mutated the data set, you're going to update your Sybil, Sybil. I don't know how to really pronounce this, Sybil or Sybil. Update your Sybil and say that the index now, right, the time index equals the trading day. And this is pretty regular, so because we've sort of eliminated the days we don't trade, and regular equals true. Okay, so again, use the pipe function and then filter because we want to extract the Facebook stock prices. We extract Facebook stock prices. If you want to extract all, you can shut this here. You can close the brackets here. But if you want to specify a particular subsample, then you might want to say between date, this is year, month, date. So you're going to specify the year, month, date again. So it's like the YYY, DD format. And you're going to say what is the starting point of your subsample and the end point of your subsample. So if you're not able to see all of these operations all together, I encourage you to go step by step, do one thing at a time. So take GAFA underscore stock and then see what happens when you group by symbol. Then do the mutation on it and take time to actually see what's going on every time to your data set. And that's how you'll get better at this. The next step is to specify an estimate and forecast. So we're going to use, again, the model function, which is powerful, and it allows us to use different models here to train our train these models to our data set. So we are going to use this, and this is pretty similar to before, so I'm not going to talk about it. But we can use the pipe function again, and we can forecast 42 days ahead. So this is trading days, remember? So this is estimating a little over a month, right? About a month and a half here. And that's pretty good for the stock market. We don't have to go way into the future. Short-term forecasts are better, although we really are bad at predicting the stock market. Now we can use the pipe function again, and we can try to auto plot. Okay. Now, what are we going to auto plot? We are going to plot the forecasts along with the series, okay, which was our training data set. FB underscore stock was our training data set. And then we can again put a level equals null, which is getting rid of those 80 to 95% confidence intervals. Give your graph a title and label your axes, and put your legend. So let's see what we get. Okay, this was a lot of code to just get this done. Now, because this is Facebook stock prices are a little more involved, but you can use the auto layer function again, in addition to that code that we wrote before, to see which model is performing better. Okay, we ignored the seasonal naive here because there is really no seasonality we see. But if you want, you could have done that as well. But we really don't know how to specify what type of season are we going to specify. Now, these simple methods are usually used as benchmark models, and we usually would compare those benchmark models to more complicated versions or complicated forecasting methods in the future. So this is a good time to actually do something similar, but with the Amazon closing price, okay? And maybe another type of time series. So produce the forecast from appropriate method for the Amazon closing price and the Australian takeaway food turnover. And yeah, we'll talk more in the next video.